Everyone, welcome to my YouTube channel. Today I am going to discuss about the pressure volume work. The figure is showing two-stroke internal combustion engines. I come to that point step by step. As we know, as we know, that is your object, any object. You applied a force and it's with the applications of this force, it's covered a distance d. D is the distance. Then we know the expressions. Work is equal to force into distance. If I denoted force by F and D is your distance in the simplest way, units are Newton meter, that is equal to joule. So that is the simple definition of a work in physics. The question is, what is the thermodynamics? That is also a branch of a science. We know about that one. So basically, thermodynamics is your heat in motion. I give you a simple example. You're driving a car, you find out you accelerate that car. If you know the distance in a specific time, you work out on the speed, velocity, decelerations when you're applying the brake. So that all about the dynamic system. When you're running a car, you use a fuel in your car. So in engines, that fuel combines with air, combustions take place, heat energy generated, that converted into the mechanical energy. So that is the energy convergence process. So that is the thermodynamic. If we follow the first law of thermodynamics, that saying energy converted into heat and work, converted into the heat plus work. If I give you one more example, in dam, moving water generate the mechanical energy in the form of running a turbines. That turbines produces electrical energy that we use in our daily life. So those are some example of a thermodynamics type system in which energy converted in the form of a heat and work. Now I come to the point that is our two-stroke internal combustion engines. If I check the components, that point is showing your piston, your crankshaft, ignition plug. Here, air intake, because any combustion process take place in the presence of air, and that is the exhaust gases coming out. Exhaust, all right. So those are the exhaust gases coming out. or you can say emissions gases. I am not sure about those spell. Right. Here, pistons move up and down, that rotating this crankshaft to complete one power cycle. So basically, power cycle is equal to up movement of a pistons and down movements of a pistons. The green sections showing your fuel or gas used for combustions. So that's mean when pistons moving up, so that's mean compressions. If you observe the figure, and when pistons moving down, that is your expansions. Compressions plus expansions complete the power cycle. That power cycle generate the work. I clarify it more by using the mathematical expressions. Right. So, that is at this point is your compressions point. Right. So at compressions, you say the volume of this gas is V1 because your gas or fuel is compressed. That is your ignition's plug that ignite the compressed gas and combustions take place. Here, that is your exhaust gases coming out from the pistons, and that exert the force and pushing the pistons towards the downward directions, and new fuel entering into the combustion chamber here, right? And when that refill with the new fuel, that's volume you can say V2. As we know, pressure is equal to force per unit area. If I, the rearrange this equation, so force is equal to pressure by area. So that is the force at this point, PA, force applied on the inner surface of the pistons that pushing the pistons towards the downward directions. Here, the pistons covered that some distance during compressions and expansions process from this point to this point. You can say that distance is equal to the length L. Now we know work is equal to force into the distance. In that case, force is pressure into the area multiply the distance that is equal to the length. Area multiply length is equal to the volume. No, that is the initial volume V1 and that is your final volume V2 here. So that is the change in volume. That change is del V denoted by V2 minus V1, right? So that is your work expressions. And if we find out the change of the volume between initial and final state, we introduce the integral by applying upper limits and lower limits, V1 and V2. So guys, that is the basic understanding how internal combustion engines work, and I relate it with the pressure volume expressions. Hopefully, this session is very useful for you people. Thank you watching for my channel. Goodbye.